Okay, so this is 11-9, tangents, radius, and arcs. And we haven't really talked about tangents a whole lot, but we're going to talk about some specific things about the tangents now. Remember our inscribed angles. Here on our inscribed angles, the x was equal to 1/2 of this angle here, this arc here, AC. Well, what if the two sides are not chords inside the circle, but what if one of the sides is on the outside like this? Well, this actually has the exact same formula. The x is equal to 1/2 of AB. It's still equal to half of the intercepted arc. It's just this intercepted arc is the whole part inside there. Now, what happens if one of those sides happens to be a chord? So this is a tangent, and this is the diameter right here. So on this side here, let's say we were looking on this side, and I want to find this angle right here. I'm going to call this one x. Well, this side of this arc is 180 degrees. So when I do 1/2 of 180 degrees, what I find is that this angle x here is 90 degrees. And that gives us that our rule is if I have a tangent and I have a radius or a diameter here, it's always perpendicular. It's always going to be perpendicular if this is a radius or a diameter. So that's a useful rule for us to have. So now we're going to do some different problems with these different rules that we have here. The first one, this is like this one here. This angle is half of the arc. Well, it tells me the arc is 78. So the question mark I'm looking for is half of 78 is 39. The next one, they gave me the angle and they want the arc. So if the angle is half the arc, I need to multiply the angle times 2. And I get that this angle out here is 210. The angle is half the arc. Now this one, notice that they want this angle here, but they gave me that arc on that side. I really need this arc on this side. So I can do 360 minus 90 and get that this side is 70 degrees. And then this angle is half of this, and I get that this angle is 85. Could I have also done it the other way and said, well, this angle here is half of this arc? So half of 190 is 95. And then if this is the straight line, these two add up to 180. And then I could have subtracted from 180 to get this side. So I really could have done it either way, and both ways are perfectly okay. Now this one is something similar to the last one we did, but here they gave me the angle and they want the arc on the other side. So I could do it either way. I think I'm going to do it this way first. This is a straight line. If this is 60, 180 minus 60 tells me this side is 120. This angle is 120. So the angle is half of the arc. So this arc out here is 240. I could have also done it the other way and said, well, this arc is half of 60, so that makes this 120, and then subtracted from 360 to get the other side. So you can go either way. Then we have some little triangles that they've put inside here, and here this is tangent to this side. So what we set up here is if it's a radius and a tangent line, they're always 90 degrees. So here, this is a radius, this is a tangent line, so this is 90 degrees here. And how would I find this angle here? Well, they gave me this angle here, and that made a triangle there. So those three angles add up to 180. So I can do 180 minus 90 minus 49, and I find that x is 41 degrees. This one, we're going to go back to something we had before. I do know that this tangent and this radius make a 90-degree angle there, but I also know that this is a radius and this is a radius of the circle, so this makes a little isosceles triangle right here because this is 63. Not the whole angle, but just this part here is 63. So I can use my fact that I know that the angles inside a triangle add up to 180 to find this one here in the middle is 54. Well, if I know that's 54, now I'm going to look at the bigger triangle here. If I look at the bigger one I just marked in green, I know that this corner of the green one is 90 degrees, this corner is 54, and now I can take those three adding up to 180 and do 180 minus 90 minus 54 to get that this angle on this side is 36. And now we're going to do a little problem here with some radiuses. It's an interesting little problem. What they're telling me here is this whole line from here to here, O to P, is 42 centimeters. And it's important that we notice that these two circles are congruent, which means that they're the same size. So their radiuses are the same size in both of them. And then it also tells me that this part in the middle, A to B, is 18 long. And what it wants to know is how long is one of the radiuses. That's what it asked me for. Well, the radius goes from O to B, so I need this part here. I mean, I know the answer is going to be between 42 and it's more than 18, but what is it? Well, if this radius is equal to this radius, that has to mean that this little part here, this is x, is equal to this little part here, x. And if I add all three of these things up, it equals 42. So I can make a little algebra problem out of this. X plus 18 plus x equals 42. And now I can solve that. X and x is 2x. Subtract the 18. And I get 2x equals 24. So x equals 12. But is that the size of the radius? No, because originally we said the radius goes from O to B, from the middle of this circle to the side of this circle. So it's not just x, but it's x plus 18. So to get the radius, I need to do x plus 18, but I found that x was 12 plus 18, and I get that the radius is 30. So you have to do a couple of steps there and keep track of which parts you're talking about as you work through it.